let's say we have the equation x squared minus 6x plus 8 now equals 0. Now, there's a lot of ways to go about this. A lot of people can instantly say this is factorable. This is just actually, I will use this in a little bit, x minus 4, x minus 2 equals 0. But let's say we didn't know that. Let's say we're not very good at factoring, and most people aren't. If you're not very good at factoring, I'm going to have a big video on factoring that'll be down here somewhere. When that's up and active, I'll have a link down here. But don't worry about it if you're not, because now we have this nifty equation that we can just use to find our zeros. So let's go ahead and do that. Let's plug in our, that's like a is 1 is a, our 6 is our b, and then our c is 8. So x's that satisfy this equation are 6 plus or minus the square root of 36, that's b squared, 6 squared is 36, minus 4 times a is 4, times c is 32, all over 2. Now 36 minus 32, that's just 4, and then the square root of 4 is just 2. So your x is equal to 6 plus 2 over 2, which is just 8 over 2, or 4, and 6 minus 2 over 2, which is just 4 over 2, which is 2. Which, hey, look at that, that's actually what we would expect if we were to factor this. The x's that make this equation correct are x equals 4 and x equals 2. Now, most people understand that, and they get that, but a lot of people don't understand this graphically. So, excuse my poor drawing skills, I'm not quite used to this new tablet. This is actually one of my first videos, so my drawing skills will hopefully improve as my video series gets larger and larger, but for now, let's try to excuse my poor drawing skills. Oh, look at that. Okay, so let's go 1, 2, 3, 4. This equation, when graphed out, you would expect that the x-intercepts, or the quote-unquote zeros, would cross the x-axis at x equals 2 and x equals 4. So it'd kind of go like down and up. That's supposed to cross through, but you get what I mean. That would be the equation of this graph, and we can see that there's two solutions. They are both on this x-axis, and they're 2 and 4. And it's really important just to see that, because a lot of times you're going to be asked to graph equations, especially in a little later in your algebra classes. And this is a very powerful technique for learning the zeros and how to graph equations. A couple things to note though. Let's say you have the equation different color. Let's go. Yeah. Let's say you have the equation x squared minus 6x plus 9 now equals 0. Now again, a lot of people can see that this factors actually into a perfect square of x minus 3 squared. But if you didn't know that, you could of course just do this quadratic equation again, or you can just get x equals negative b, that's 6 plus or minus square root of 36 minus 4 times 1 is 4 times 9 is 36 all over 2, and that's just 0, so it's just 6 plus or minus 0, which is 6, over 2 equals 3, which is exactly what we'd expect. And so when you graph this out, 1, 2, 3, you would expect that this kind of goes like, this crosses only at one point. It kind of comes down, and then it just touches that axis, and then it goes right back up. only at one point at x equals 3 does the axis actually intersect with this function. Just barely touches it. And then we have, of course, the odd solution that no one likes to talk about, but it's there, and we have to acknowledge its existence. Let's say we had x equals, x squared plus 3x plus 4. Yeah. Now, this doesn't factor out very easily. In fact, it doesn't factor at all, but that's what we're actually getting into right now. If we were to plug this into the quadratic equation, we would get negative 3 plus or minus square root of 9 minus 16. 4 times 4 times 1 is 16 over 2. And it equals 0, by the way. Equals 0. Yeah, equals x. And now this is bad because that's what, negative 7? Yeah, negative 7. Yeah. And we've always learned that you can't have a negative under the radical, and that's true for the most part. When you're talking in this this level of mathematics, having a negative in this radical is a really bad thing to happen. And I'm not going to go into what this actually is. These are imaginary numbers, and they're not too difficult, and you're probably going to go into them in the same class that you're in, that you're learning the quadratic equation, and probably not too far along later either, but I won't go into it. But just something to take note of, when this kind of thing happens, when you graph this out, terrible, whatever, it's going to look something like this. It doesn't ever touch the x-axis. It doesn't have any zeros, which makes sense. There's no x you can plug into this equation. There's no x that you can plug into this equation that makes this equality equals 0 true. So all in all, we can notice one thing. There's a special term for this b squared minus 4ac. This is called the discriminant. And there's 3 cases that we've already discussed up here. One case, this is positive. And when this is positive, we're going to have 2 roots, or zeros, or solutions, whatever your particular instructor calls them, but you can have 2 of them. It's going to cross the x-axis twice, like happened there. Crossed it twice, because this was positive. We have the second, where this equals 0. And when that happens, we have 1 root, or solution, or 0, or whatever, like we had here, where it just touches the x-axis. And that's, when that happens, you have a perfect square. And we have the last bit where this discriminant is negative, in which case we have 0 roots, or zeros, or solutions, in which case it never touches the x-axis. And that's something to really take from, I think I went too far up. Yeah, there we go. That's something to actually really take from this in general. This discriminant is a very important thing in quadratics. If you can find if your b squared minus 4ac is any one of these 3 sets, then you can instantly find how many real roots your solution is going to have. And from that, you can do a whole host of things, including graphing and finding solutions.